Welcome to the CopyCat Masterclass. In this series of videos, we'll share insights on how to get the most out of Nuke's CopyCat nodes and harness the power of machine learning in your workflows. We'll discuss strategies to select the best inputs, pick the right training settings, and troubleshoot common training challenges.
Hi, I'm Mairead.
And hi, I'm Johanna.
And we're both senior research engineers working on CopyCat. And in this first video, we'll begin with a foundational understanding of how CopyCat operates and the magic behind its training process. So, how does CopyCat work? Well, CopyCat is a machine learning node in Nuke, which allows artists to train their own neural network specific to the shot or set of shots that they're working on. And how it works is that you can give CopyCat a small set of before and after images, and it will learn to replicate the transformation from one to the other. And the target images are typically called ground truth images. And CopyCat does this by training the CopyCat model, which is a trainable neural network. So for instance, if you were trying to train a human matting model for a specific shot with a running girl, you could give CopyCat a few frames of that shot with their corresponding ground truth mat. And then the CopyCat model will learn to replicate this effect. And after the training is finished, you'll be able to apply the trained model to the entire sequence.
And the training process would look like this. Once you've provided input and ground truth images to your CopyCat node, we can start training. The training occurs across a number of iterations or steps. At step 0, one input image will be run through the CopyCat model. And we get out an output image. At first, the model, which is randomly initialized, will not produce great results. The model contains what we call model weights, which are a set of learnable parameters. You can think of the model weights as a set of magic numbers running some mathematical operations on top of your input image to give you a certain output. And during training, these parameters are adjusted to be able to learn the desired transformation. Now that we have our output image, we compare the model's output with the ground truth to gauge its performance. This comparison value is called the loss. It tells us how far away we are from the image we are trying to achieve. The closer the output is to the ground truth, the better the model is. This loss guides the model in adjusting its parameters in the right direction, step by step. After repeated iterations, the model starts to make sense of the data, and it is eventually able to generalize across all the frames. And that is how CopyCat training works under the hood.
So CopyCat can learn a great variety of tasks. It performs very well for in-painting use cases like beauty work or marker removal, as well as for garbage matting tasks such as human matting. In the next video, we'll discuss the best strategies for selecting the CopyCat input data on different shot examples. So take a look at our sizzle reel for more examples.
This is CopyCat. What it does is up to you.